In this video, we will discuss automatic exposure controls, what they are, and how to use them wisely. Automatic exposure controls, or AECs, were developed to produce more consistent exposures, reduce repeat exposures, and decrease patient dose. The simplified concept behind AECs is a detector is in place behind or after the patient, and the remnant beam or the X-rays that have passed through the patient or the body part interact with this sensor. Once the detector senses the preset amount of radiation, it terminates the exposure. The AEC controls the amount of time the exposure is active. All other factors are set by the radiographer, including the kVp and MA. Time is the variable that the AEC is affecting. We will review this process in more detail as we are discussing the two types of AECs. The first AEC we will discuss is phototimers. They were developed in 1942. Phototimers measure the light emitted from a fluorescent screen. This light is then converted into an electrical charge, which is stored in a capacitor. When enough electrical charge is detected, the exposure is terminated. These are no longer in use, but the term phototiming is still used by some radiographers when referring to the use of AEC. In most AEC systems, the type of device used for radiation detection is the gas ion chamber. In an ion chamber, electrons are freed from air when radiation ionizes it. These electrons are attracted to a positive anode where they accumulate to form current flowing down a wire where it is amplified and measured. Once the set amount of charge is reached, the exposure is terminated. The ion chambers are thin, flat rectangles with air trapped between two sheets of plexiglass or aluminum. Ion chambers are mounted just under the table or bucky surface, but in front of the image receptor. They do not cause artifacts on the image. The gas ion chambers are usually arranged in a triad. The top two chambers are spaced more laterally and superiorly, and one is located centrally. Some digital units use 5 ion chamber detectors. There are two switches that control the main circuit: the manual exposure switch held down by the radiographer, and the automatic switch controlled by the AEC circuit. Now, just to be clear, the AEC does not actually time anything. It simply stores or counts up accumulated electrical charge until a preset amount is reached. It is when this amount of charge is reached that the exposure is shut off. Therefore, the actual time that the AEC exposure lasts is ultimately determined by the rate of exposure reaching the detector cells underneath the patient. There are a number of things that you need to keep in mind when using AEC. Most density controls alter the exposure in steps of 25%. The AEC compensates for any change that occurs in front of the table. It cannot compensate for changes in grids, cassettes, or detector plates behind the detector cells. It must be reset by a technologist or physicist when changes in receptor systems are made. AEC does improve the consistency of exposures for most procedures, but is not the answer for every situation. Manual technique skills are still important for the radiographer to develop. The AEC must be used with good judgment. This includes selecting the correct ion chamber detectors to be activated and understanding what exams are not conducive to AEC. You should avoid using AEC when the anatomy does not cover an entire ion chamber detector, or is peripheral to that detector. Such is the case with the clavicle. Notice that the raw, unattenuated beam is reaching a portion of the detector. This will cause the sensor to terminate the exposure prematurely, since the rate of exposure will increase due to more radiation reaching the detector faster. Other exams where this could be an issue include the lateral scapula Y view, the sternum, mandible, zygomatic arches, and the patella. These exams are best exposed with a manual technique.